Temperature is a controlled condition. It is monitored by receptors in the skin and elsewhere, and they communicate changes to the hypothalamus of the brain. This control center can then coordinate the action of muscles, sweat glands, and blood vessels. These effectors can bring body temperature back to normal conditions. If, for example, body temperature were to rise, receptors would detect this increase and communicate this with the hypothalamus. The hypothalamus would then cause vasodilation of blood vessels going to the skin and the secretion of water from sweat glands to help cool the body, and this would return body temperature to normal. If body temperature were to decrease, receptors would detect this, and then the hypothalamus would direct the vasoconstriction of blood vessels going to the skin so that blood would be directed deeper into the body so that heat would not be lost. The hypothalamus would then produce hormones which would ultimately cause the contraction of skeletal muscle, which would generate heat and help restore body temperature to normal. Thus, homeostatic mechanisms must maintain body temperature within a narrow range. Should body temperature become too high, then a number of deleterious effects, such as the changing of the shape of proteins, would then inactivate their function. Should body temperature become too low, then many chemical reactions would not occur at rates fast enough to maintain life. And so, homeostatic mechanisms must maintain body temperature within a narrow accepted range.